go for the waveguide teaser, which is very important topic here and also very simple to understand here. Waveguide teaser is nothing but here again this is a 3-port terminal here. Usually this is kind of an waveguide teaser used to combine the power here. If at all you wanted to combine the power or we wanted to divide the power here, we split up into 2 ports here. Okay, so based on that one here, we are having waveguide T's here, and we were having something called as E-plane T or E-plane waveguide here, and also we are having H-plane waveguide here. Based on the what kind of ports we are trying to use here, based on that one it is been defined here, right? H field is there, or electric field is there, or magnetic field is there. Based on that one, E plane, H plane is defined here. Okay, so the matrix which is given in S matrix is the general S matrix of the T junction here. Remember, T junction is nothing but here 3-port is there. So S11, S12, S13, S12, 22, 23, 13, 23, 3 here. This is what is the S matrix representation of T junction here. Okay, nothing but here 3 ports will be there here. Okay, so that is what is this matrix representation here. Okay, and this always remember here. We don't have any kind of a non-linear components here or non-linear elements here. So what is going to happen here is this is symmetry we can achieve in this particular Sij is equal to Sji here. Okay, that is S12 is equal to S21 here. We can have that kind of arrangement here in this microwave waveguide T here. Okay, let us understand what 3 sections are there here. We can understand. First one is E-plane T. Okay, now just look into this particular figure here. What is the figure shows here? There is port 1, port 2, and port 3 here. Okay, so port 1 and port 3 are the collinear arms here, right? They are opposite to each other here. Port 3 is just perpendicular to port 2 and port 1 here. It's nothing but here side arm is called as. Okay, I think figure is very clearly visible. Yes or no? Can you just answer me? Hello.
Yes, sir.
Okay, so this is what is a 3-port terminals here. Port 1, port 2, port 3. Port 1 is exactly opposite of port 2, and port 3 is perpendicular, or you can say exactly at a 90 degree to the port 2 and port 1 here. Okay, now whenever a microwave signal is there, this particular signal, if at all it is been incident at a port 3 here. Okay, what it is now? Microwave signal is incident at port 3. Okay, the electric field lines whatever we are having is there, no? They will be splitted into 2 here. That is, they are going to transmit to the port 1 and port 2 here. Okay, they will come out of the port 1 and port 2 here. But what is exactly the magnitude and the phase here? With what magnitude they are going to come? With what phase they are going to come out of port 1 and port 2 here? Okay, remember here, whenever a microwave signal is incident at port 3 here, okay, the output of a port 1 and port 2 magnitude will be same, but there is a phase shift of 180 degree with the 2 here, that is 1 and 2 ports here. Okay, so due to, remember here, there is a 180 degree phase shift in the output of the port 1 and port 2 here. Okay, input is port 3 here, so that is called as the side arm here, or is also called as the ER here. Okay, remember ER. Okay, now as we have mentioned the condition as due to symmetry, a plane of symmetry here, signal is fed at a port 3 divides equally here. Remember, whatever the signal we are going to fed into port 3 here, it will be equally divided between the port 1 and the port 2. But the only thing is that this 180 degree out of phase here. And hence, what about the scattering coefficients here? We have to write the S matrix for this E-plane T here. S matrix is nothing but again S12, S11, S13 like this, S21, 22, 23, and S31, 32, 33. All these 9 S parameters we have to write for this E-plane T here. Okay. Now we know that scattering coefficients 3 to 1, that is port number port 3 to 1, this is 3 to 1 and 3 to 2 here, are equal in magnitude here but opposite in phase here. That is nothing but here we will be having 3 to That is S32 is equal to minus of S31 here. Okay, they are opposite here. That's what the minus sign has been taken here. Now assume that the port 3 is perfectly matched here. At perfectly matched means what here? There is no reflection here. Perfectly matched junction, if at all we say, there is no reflection towards the port 3 here, and hence we will be having what is S33 is equal to 0 here. Okay, there is symmetry property we are using for the S matrix here. Sij is equal to Sji. That means here S12 is equal to S21. S13 is equal to S31. Okay, like this we can mention here. Like see here, you can mention in here S232 is equal to 23. S32 is also equal to S minus 31. S13 is equal to 31 here. If this is the case here, how exactly our S matrix could be written here? See, S matrix is equal to S11, S12, S13. This first row will remain as it is now. Now let us understand the second row here. Second row, what is second row? In this particular place, we will be having S21 here. Second row, first column. 21 means what here? Second row, first column. So S21 is equal to what here? S21 is equal to S12. We can also write here, right? Due to the property of what here? Symmetric property here. So that's why I have written here S12. Okay. S22 is nothing but again the reflection coefficient here, which we don't know, which we don't have any value here. We have not treated port 1 and port 2 as perfectly matched here. Remember, port 1 and port 2 are not perfectly matched as of now. So only port 3 is matched here. That's why we are having S33 is equal to 0 here. Okay. Again, the same thing here. Yes, this is second row is there. The third column is there. S23. S23. What it is there here? S23 is also equal to S32 here. S32 is also equal to minus S31 here. Minus S31 is equal to 13 here. So that's why we can also represent S23 is equal to S13 here. Okay, that is minus you can take here. The same way here also. This third row, first column is 31. 31 could be represented with 13 here. The second, again, third row, second column, third row, second column will also be represented with minus of S13 here. So what we are doing here is that in this particular S matrix here, we are trying to bring it with one variable itself here. Okay, that is S11, S12, S13 here. Okay, so it will be easier for us to find the values here. Okay. Now again, we'll consider the unitary property of the equation here. That is S into S conjugate is equal to whatever the U is there here, right? S into S conjugate. You know, you take the conjugate of the S here, and you can multiply with the S matrix, and it is been equated to the unit matrix here. So how many equations we need to find here? I think I have told here we have to find out 9 equations here. Instead of 9 equations here, or you can say 9 variables we have to find in it. If we wanted to find the 9 variables means 9 equations we need to have, right? So what we'll do here is we'll take only the first 4 here. Remember, first 4 will take here. That is, I will multiply the first row of the first matrix with the first column of the second matrix here. Remember, that's why we will get a S11 square, S12, and S13 is equal to 1 here. Right? First row of the first matrix and first column of the second matrix has been multiplied, and it is equated to 1 here. That is unitary matrix we are having. In the same way, you have to do here. That's all the second row of the first matrix to the second column of the second matrix, you will have the answer is equal to 1 here. That's how we are getting here. And also third row of the first matrix to the third column of the first matrix, we will be having the answer as 1 here. Right? So using these are 3 equations here. One more equation is you have to multiply the first you have to multiply the last row of the first matrix, it is third row of the first matrix with the first, what you can say that, first column of the second matrix here. These are the 4 equations you have to take here. Remember, first row of the first matrix to the first column of the second matrix. In a similar way, second row to the second column, third row to the third column, first and the second matrix. Last equation is third row the first column, the first and the second matrix here. That all we take here, we get some answers. So using these four equations here, we are able to get the values of all the nine variables here. Okay, you can see here using the third equation here, that is s13 square plus s13 square is equal to 1 is there. We can write it as 2 of s13 square is equal to 1. So s13 can be written as 1 divided by root 2 here. Okay, so this again in the fourth equation we can take it as s13 can be taken as a common here. S13 can be taken as a common, and S11 is equal to S12 you will have. If at all you take the conjugate out here, that's how you will get S11 is equal to S12 here. You also know that the reflection coefficient S11 is equal to S22 here, right? Okay, then we are having the three here. S13 we got here, S11 we got here, S12 and S22 we got here. So again in the equation here, you know S11 is it written as it is now. We don't know the value of S12 here, but we know what it is equivalent to. So we can mention it as S11 here. Okay, we know the value of S13. Okay, so we will get definitely there is only one term which is unknown here, and hence we will get the S11 value here. S11 value is equal to 1 by 2, which is equal to 1 2 and 2 2 here, right? So we got all the values of S11 and 2 2 3 or 3 2 or 1 3 3 1 S33. So substituting all the S parameter values in particular matrix here, you will get this S matrix here. So that is S is equal to 1 by 2 to the square matrix here, 1 1 root 2 1 1 1 minus 2 root 2 and root 2 minus root 2 0 here. This is how we are going to get the E plane T junction S matrix here. Remember, in the similar manner we have to find out regarding the H plane here. That is, remember the steps here. What you have to do here is first assume that there is not assumption here. Whenever there is an input signal is there at the port 3 here, it is going to be splitted equally between the port 1 and port 3, but it is out of phase. That's why we'll have the minus here. Okay, then you should assume that the port 3 is perfectly matched here, then will be equal to 0 here, and you have to obey the symmetry property here, and hence we'll be having these three equations here. Okay, with these three equations here, and after that we have to consider the unitary property here. Unitary property is S into S conjugate is equal to unitary is there, that you have to mention here, and then take the four equations here. With the help of the four equations here, okay, you can derive all the terms, that is S11 to S33 values you can derive, and then you can substitute that particular values into the S matrix here. You will get the S matrix for the E plane T junction here. Okay. In similar fashion here, in the similar fashion, it will be contained with the H plane here. Remember here, H plane is there. We have seen that the port 3 is exactly perpendicular here. Here also it is perpendicular, but it is placed at the downside here. Okay, so this is called as H arm here. H arm in the H plane here, and E arm in the E plane T here. Remember here, again the same port are there here, port 1 and port 2, which are opposite to each other here. Okay, whenever there is an input signal, or you can say microwave signal is been incident to port 3 here. Okay, equal magnitude, and remember here the phase is also equal here. Remember, equal phase and magnitude will be coming out of the port 1 and the port 3 here. That's why here S31 is equal to S32. In the previous case it was 180 degree out of phase. In this case it is equal both in magnitude and the phase here. Again the same thing we have to use here, except the minus thing here. Again the port 3 is perfectly matched here. S33 is equal to 0. Again you have to obey the symmetry property here. Okay, using the symmetry property here, you should write all the terms of the 2 3 3 2 in terms of 1 3 and all things here. Thereafter again you have to use the unitary property of this particular equation here. Just cross multiply. Instead of having the 9 equations here, just have the 4 equations as I told. First row of the first column, the first matrix will be multiplied with the first column of the second matrix. In the same way, you have to multiply second row the first matrix to the second column of the second matrix, third row of the first matrix with the third column of the second matrix, and the last equation is third row of the first matrix to the first column of the second matrix. If at all you do all these things, you will have the answer all the parameters of S11, S12, S2, S13, so on. Okay, so again the same thing you have to do here is just add up this S13, S13, you will get S13 is equal to 1 divided by root 3 here. Here little bit of minus is there here, no? S12 is equal to minus S11 is there here. Okay, in the previous case it was S12 is equal to S11 we are having here. Okay, so again one unknown parameter is that if at all you substitute this S11 in place of S12, no, we are having already the modulus is there, no? So that's why we are getting again the S11 is equal to 1 by 2 here. And again you can write S is equal to 1 by 2 instead of having the minus at the third row and sorry, second row and third column. Here we'll be having in the first row second column and second row first column here minus sign. Okay, this is how we can get the S parameter or S matrix for the H plane T junction here. Very easy to understand. If you at all you understand the E plane, it's quite easy to understand the H plane also here. The last one of this class is EH plane here. That means we are trying to use both the ports here, that is ER and HR here. It is a 4-port network here, 4-port network here. Okay, 4-port T junction you can consider. E and H plane T's you can consider. It is also called as a hybrid or magic T here. Okay, so what is now EH plane? EH plane means obviously they are having the 4 ports are there here. 4 ports are there, so obviously we will be having the 4 into 4 matrix here. So what we have to do is scattering matrix. They will be asking questions here. Represent the S matrix for the EH plane or hybrid port here. Sorry, or a magic T here. So at that time we have to draw this particular ES into EH and write all these components S112, S44 you have to write here. So you people are very much aware of E plane. Whenever there is an incident or wave is there or input wave is there at the port number 3, so what is going to happen? It will be distributed equally in terms of magnitude, but it is out of phase for the it is out of phase, that is for the port 1 and port 3 here when there is an incident wave in the port 3. So that means there is a minus sign. 32 is equal to minus 31 here. Okay, whenever there is an incident wave at the port 4 here, that is nothing but H plane here, magnitude and phase are equal. That's why 42 is equal to 41 here. So these two parameters can be utilized in the S matrix representation, and we already know that. So whenever there is a wave incident is there at a port 3 here, the wave is equally divided between the port 1 and port 3, but there is no wave which is going to be traveling in the port 4 here when there is an incident in the port 3. That's why 3-4 is equal to 0. The similar manner, whenever there is an incident wave at a port 4 is there here, there is a equal divide of magnitude and phase with the port 1 and the port 2, but there is no magnitude or phase in the port 3 here. That's why port 3 is equal to 0. Okay, because they behave as an isolated ports here. Whenever we are using the port 3 as an input port, port 4 will be isolated. Whenever we are trying to use the port 4, okay, port 3 will be isolated here. That's why they are called as a magic T here. On the port there is an input is there, only the 2 ports will be operated, port 1 and port 2. The other port will not be operated here. That's why it is called the magic T here. Okay, right. So this is again 3-4 and 4-3. Okay, you know, is equal to 0. Then if at all we assume that our H arm and E arm are perfectly matched here, then port number 3-3 and port 4-4 is equal to 0 here. And again symmetry property, if I try to use it, yes, Ij is equal to yes, Ji is there here, right? So using all these 4 conditions here, remember first one is due to the E plane, second one H plane, third one is your isolated port here, fourth one is perfectly matched, and symmetry. Using these 5 conditions here, what we can do here is we can write the S matrix here. Further simplification of the S matrix of the 4 ports here. So then what we're having again S21, S12, like this we can write here and write the S matrix here. So once we got the S matrix here, just use the unitary property S into S conjugate. You will have this unitary property. So unitary property applied to the rows 1 and 2 here. If at all we apply this rows 1 and 2 here, what is going to happen? Row 1 is been multiplied with the column 1 of the second matrix, and again same thing, it has been there here. So if at all we do here, we will be having this particular S22 is equal to S11 here. And again unitary property has been applied to the rows 3 and 4. We are trying to apply this rows 3 and rows 4 here. Okay, right. So this is row 3 is been row 3 of the first matrix has been multiplied with the column 3 the second matrix. Row 3, sorry, row 4 has been multiplied with the column 4 of the second matrix. If at all we multiply, we get this S13 and S14 is equal to 1 by root 4. Okay, once we got the value of 13 and 14 here, you substitute in the equation number 1 here. Okay, you will get this equation here. Okay, the only solution we have is both must be 0 here. S11 and S12 is equal to 0. If at all that is the case here, then you have to identify, if at all we wanted to have this S12 and S11 is equal to 0, obviously both should be equal to 0 here. So then again we'll be having this collinear ports are perfectly matched to the junction. So with this one, what we're having here, all the ports values we have got here, S12, S13, all the ports are value we got here, and hence we can substitute in the this matrix here. We'll have this particular equation here. S magic T, MT you can also write here. MT is equal to 1 divided by root 2 into bracket of all these zeros and ones you can write here. This 4 into 4 matrix here. Okay, that's why whenever two ports of a 4-port junction are perfectly matched here, then the remaining 2 ports are automatically matched to the junction. Such a junction where all the ports are perfectly matched to the junction is called the magic T here. Okay, that's why when 2 ports are matched, that means port 3 and port 4 are being matched. Obviously, other 2 ports are also matched here. That's why it is called as a magic T. Or we can also say in this way here, whenever there is an incident wave at a port 3, there is no output at a port 4. Only port 1 and port 2 we have the output here. That's why it is magically appearing at 1 and 2. It does not appear at a port 4. The same way, port 4 input, there is no output at a port 3, but there is an output at a port 1 and port 2. And hence it is called the magic T also, you can mention here. So applications of the magic T. Magic T has a number of applications in the various microwave circuits here. Could be used as the power combiner. Yes, obviously that is the one thing which we are trying to use here. Okay, E and H tuner. Okay, with the help of the magic here, we're trying to tune the particular impedance matching here, and also in the duplexer you can use it, balance mixture you can use it, and also in terms of the bridge here for the measurement of impedances at microwave frequencies here. Okay, these are the 5 applications which we are having here for the magic T here. Okay. So this is how we are able to understand the microwave passive devices here. Anybody has any doubt, please let me know here. This completes your microwave passive devices here. Anybody has any doubt regarding all the 4 devices here? Okay. Based on this also there will be problems here which I'm going to solve in the next class here. But today only just understanding of all these microwave devices here. Remember 4 microwave devices we are having here. One is coaxial attenuator here, and then coaxial connector here, then attenuators here, then phase shifters here, waveguide tiers here. Coaxial cable, coaxial connectors, we are having so many connectors to discuss. Attenuators, remember fixed, variable, and precision variable attenuator here. Remember, precision variable attenuator is a very important one here. Many times it has been asked here. Phase shifters again is a very simple topic here. Just changing the phase shift with the help of the wave velocity and whatever the length of the dielectric slab is there here. Waveguide T series is nothing but here 3 port terminals are there. That is H plane, E plane, and EH plane is there here. Okay. Remember in the E plane port 3 there will be a same magnitude phase will be shifted. In the H plane, same magnitude and the same phase here, there will be different set of matrix values will be there here. And EH plane is there, both are available. same magnitude out of phase, same magnitude with phase here. Okay, both the things we have tried here. That is EH plane here. This is also called as a magic T here. Anybody has any doubt here? Guys?
No, sir.
No? Okay. Anybody
No,
else?
sir.
If at all you have any doubts here, just put it into the comment box here. I mean, in the messages chat here. Okay. And if anyway, I have what I can say that I have given the notes here, updated in the Google Classroom here, just to go through that particular uh, uh, notes here. Once you read here, it will be easier to understand. Remember, problems will be coming on the magic T's here. Last three are there: E plane, H plane, and the EH plane is here. And also many questions has been asked on that particular topic here, carrying around 8 marks here, because we have to derive that matrix now. Try to practice that matrix here. Okay, you have to derive that 3 into 3 matrix or 4 into 4 matrix here, EH plane matrix. You have to derive. Okay, so if at all you have any problem in understanding, please let me know. Okay. Okay then. These many students are present. Fine. Anyway, the video will be there here. I will be sharing that video also here. Right? Okay. Thank you. You can leave the class here. If at all you have any doubts here, please message me. And try to read all the notes which I have uploaded in the Google Classroom here, because your exams are going to be very near here. Okay? 11, 12 or 13. Thank you.